Now what we're going to look at is figuring out how many solutions an equation should have, which is kind of a tricky concept. So what we're going to do is we're going to graph each one of these systems of equations. Now it's just going to be kind of a rough graph and figure out how many equation answers we should have. So what's the y-intercept of this one? +5. That one is +5, so it's up here somewhere. And it's going up or down? Up at a rate of what? 1/1. So it's doing a line like this. Right? Going forever both ways. What is the y-intercept of the next graph? This one. +1, so it's about here. And it's going down at a rate of 1 and 1. So it's going to be a line like this. How many intersections are there? So how many solutions are there to this system of equations? Just one. So if there's only one intersection, there's only one answer, one solution to the system of equations. Let's try this one. What is the y-intercept of that, Matthew? Y-intercept of this question. -8, so somewhere down here. Is it going up or down? Up at a rate of what time? 2, right. So it's going up kind of like this. What is the y-intercept of the next equation, Reagan? Yeah, this one, sorry. 6. So it's somewhere up here. And what's the rate it's going up by? 2 again. So it's going up the same way. And Matthew, what did you just say? They're parallel. How did you know they're parallel before we even drew it, Matthew? The slope is the exact same. So, lines that have different y-intercepts, but the exact same slopes, have how many solutions? 0. There is no solution. So if you have parallel lines, there's no intersection, meaning there's no solution to the problem. They have to have different y-intercepts and similar, the exact same slope. All right, let's look at the next one. What's the y-intercept of this? Josh?
-2.
You got it. Down here. What's the slope, Weston? So the slope of this one was 2. What's the slope of this one, do you think? 3. Yeah, so it's going up 3 for every run of 1. Next equation. Is the y-intercept easy?
Yeah.
It's not given to us right away, so we have to do some algebra. Since the y is negative, I want to move the y to the other side, so I want to plus 2y to both sides. So my next equation would be 6x minus 4 is equal to 2y. We don't want 2y, we want 1y, so how do we get rid of the 2? Divide by, you got it, divide everything by 2. So now you have the equation in this form, right in red over here. It'll be 3x minus 2 is equal to y. So, where is our y-intercept? Minus 2. So, it's down here, same spot. What's our slope? 3. Same slope. So, it's going to be the same line. So, let's take a review. This one had one solution. This one has no solution. How many solutions are in this one? We heard negative, we heard 0, heard 1. Aaron, take a guess? Endless. What do we call it if it's endless? Not undefined. Infinity. So this one has infinite answers, and that's the sign for infinity. It's like a sideways 8. So it has an infinite number of solutions. Infinite number of solutions, meaning that we could find any point on the lines, and it would be a point for both lines. Which makes sense. It's where they hit, right? And they're hitting everywhere all the time. You're going to get that on the test. Promise, guarantee it's going to pop up. Infinite solutions if the lines are on top of each other. Your instinct is to say 0 solutions or 1 solution. Infinite. Okay. So, let's do another quick review. If you have different slopes, different y-intercepts, how many solutions do you get? 1. If you have the same y-intercept and the same slope, you have infinite. Same slope, same y-intercept. Infinite solutions. Different y-intercept, same slope. Parallel lines, no solution. Beautiful.
Will we have to do the solution for like curved lines?
That might be something we do, like non-linear lines. Yeah. We're going to talk about that. Okay. So, 1 solution, 0 solution, infinite solutions. The lines would look like this, or this, or this. Right on top of each other. For this one, the slopes are what? They don't have to be perpendicular, they just have to be different. That one looks like they are perpendicular, doesn't it? So perpendicular lines would have 1 intersection. The key is the slope is just different. And the y-intercept, if the y-intercept was the same, would it work? Would it have a solution if the y-intercepts are the same? Yeah, the solution would just be your y-intercept. So the y-intercept can be anything. But the slopes have to be different. For 0 solutions, what's the slope got to be, time? Exact same. And Kendall, what does our y-intercept have to be for 0 solutions? Different. And if we want the 2 lines to be on top of each other, what do we want? Same everything. Same slope, same y-intercept. Matthew. They don't have to be perpendicular to have 1. Perpendicular does work, but as long as they're different slopes, you're good. So if the slope is 1 and the slope is 2, you're good. If the slope is 1.99 and the other slope is 2, would it have an intersection? Yes, somewhere. It might take a long time to find it because they're barely ever going to really merge together, but they will merge together eventually. So anything different gives you 1 solution, even if it's the smallest margin. So we just did all that here without graphing. We figured it out. Word problems. What's the worst part about a word problem? In your opinion, the worst part. The words, having to read all the words sucks. Julie, what do you think? Distractions. So all the useless junk that you don't need in the question. What else, Johnny? how it's worded, so trying to interpret what's being said to you. Yeah, what else, Josh?
The part you're saying, well, this can happen.
Yeah.
Like, who buys 500 watermelons?
Yeah, the illogical questions where it's like, yeah, somebody jumped 20 meters in the air. Who can jump 20 meters in the air? Yeah.
Lots of people.
The illogical problems. Liam. Liam. Oh, come on. Yeah, the illogical problems. Okay. So when you read these beautiful questions, if you struggle with interpreting what they say, which is like the main thing, or you struggle with understanding what kind of stuff is garbage and what stuff isn't, try underlining information that you think is important. So as you're reading it, a local high school student council decided to see hoodies. Okay, so you're checking out hoodies. Just a long sentence for, let's go look at hoodies. The cost of designing the hoodies is $600 plus $5 each. That's important. So the cost to design a hoodie costs you $600 plus $5 for every hoodie. So $600 basically for the design, $500 to basically make them. The student council plans to sell them, or not see them, for $25 each. The cost and revenue can be represented by the following system of equations, where T represents the cost and N represents the number of hoodies sold. All this other stuff is pretty much junk. Who cares that it was a local high school student council? I sure as hell don't. Like, it doesn't matter.
You're on the council.
If you're on the council, maybe you care. Who here's on that council? Me. Aaron. So this will be useful for Aaron only.
I'm paying $600.
What's the cost of hoodies in dollars? So cost is equal to what, Josh?
Cost equal to 5 times 600.
Yeah, $5 for each hoodie, 5N, plus they charge you $600 just to get their design. Now, how much money are you making when you sell? The revenue means money made. So how much money do you make? How do you figure out how much money you made? Austin, how do you think you figure out how much money you made? So how much are we selling hoodies for? $25. So $25 times each hoodie sold will tell you how much money you made. So revenue is just money coming in, not profit. Profit, you'd have to subtract out your costs. So that's right. That would be if you're looking for profit. Revenue is just straight up the cash coming in. Aaron.
They wouldn't make money, wouldn't they? Because it's $600 per hoodie.
Right, but let's take a look. What's every hoodie you sell? You're making $25, but every hoodie you had to buy to sell cost you an extra $5. So at some point, you're making revenue at a higher rate than your cost is. So you're right. If you sold 0 hoodies, it would cost you $600 just for the design. You made no money. But if you sold 1,000 hoodies, you would have $25,000 here in revenue, but the cost would have only been $5,600. So you would have made just shy of 20 grand. So what we need to do is this is actually applicable, is you need to find the breaking point of when you're going to make money and when you're going to lose money. And that point would be the solution to the system of equations. What's up? You know the answer? Okay, beautiful. Let's see, did you use your graphing calculator? You figured it out? Okay. What's the answer? So, our hypothesis from Reese is that You break even at 125 hoodies. What we are going to do is we're going to graph it in our calculator and see if we can do it. So, in your calculator, you need to punch in these two different equations. You need to set an appropriate window on your own. Then you need to calculate the intersection. All on your own. Give it a shot with your calculator. You check it on your own, man. I don't know either. I'm trying to figure it out also.
Guess you suck.
Really? Oh man, that was good. I was sleeping and you just touched my stone. You. I can't let you take this. Good job. You know what? I give you a
Okay. Yeah. Aaron, don't have an answer? You have a question? Okay. What I set my window to is, and your window can be completely different. I knew my Y min and my X min can both be 0. Because I only want to see the positive side of the graph. So if you have a graph like this, I know that I'm not going to have negative dollars, so I don't need that or that. And I know I'm not going to sell negative hoodies, so I don't need that. So I only worked within my Y min of 0 and my X min of 0. And then I kind of looked at this equation, and I understood that my y-intercept of that one was already 600. So my y max is going to have to be really big. So I made my y max like 1,000. And then my end value, I was like, how many hoodies could you reasonably sell? I mean, like, we're not going to sell 1 million hoodies, so why would I make my X max 1 million? I made my X max 50. I figured that'd be a good number of hoodies to sell. Is that what you did? Beauty. I did that, came out with a graph, I could see the intersection, I was pretty happy. If your graph looks kind of funky, or like the scale's really whack, if you were to draw this thing out, so I chose this, my graph is like this, right? 0 to 50, and 0 to 1,000. If I were to draw this by hand, what would my scale be going up? Probably like 100. Right? I'm not going to draw every single dot. So I made my Y scale 100. My X scale, I'm probably going to go up by 10s, 5s. 5s would work. So make your X scale 5. Maybe make it 10. And when you graph, you'll see your graph will look a little bit prettier and make a little bit more sense. Now, who remembers how to calculate the intersection? What do you have to do, Joe, to calculate the intersection on your calculator? Second trace 5, or the intersect button, and then enter, enter, enter. And your answer should have been X is equal to 30. Y is equal to 750. Is that what everybody else got? Josh?
Put it in ordered pair.
Yep. So you can put it in the order pair. What does this order pair actually mean? That's the solution. That's the solution to my equation.
That's how many.
But what does it mean? How many what? Yep.
That bottom.
X, aka N,
Oh, yeah.
is the number of hoodies that we have to sell. That's the number of hoodies we have to sell if we want our cost to be equal to our revenue. So that's the minimum number of hoodies we have to sell to start making money. So the 29th hoodie, we still aren't making money. The 30th hoodie, we broke even, 0. The 31st hoodie, we made a profit.
Wait, how many is it?
30.
30.
Our intersection was 30, 750. What does the 750 represent, Lana? You have a question? Okay, go to something else. You break even at 29?
The cost of the house is 6.
So 29 times 25 and 29 quarter times 5 plus 600. So if we put 29 into this equation, the cost would equal $745. If we put 29 into this equation, the revenue would be $725. So we have lost money. The 29th hoodie still lost money. The 30th hoodie, dead even. 31st hoodie, made a profit. Joe. Okay, wait 2 seconds. We're just about done. So, how much profit or loss is made if we sell 20 hoodies? You have to take 20, put it into both equations, and figure it out. So 5 times 20 plus 600. And then 25 times 20. This is our cost, that's our revenue. Your cost should be 20 times 5, should be $700. Your revenue should have been 25 times 20 is $500. How much money did we make? Did we make it or lose it? We lost it. We lost $200 because we didn't sell enough hoodies. 50 hoodies sold, do the same steps. Just sub the number in here and here. You should get 50 times 5 plus 600. The cost should be $850. Your profit should be $1250. So you made $400.
You do 50 times 20.
Yeah, 50 times 25. Because we were selling each hoodie for $25. The break-even point. Break-even point. That's the point where you didn't make any money, but you didn't lose any money. What was our break-even point again? 30. 30 comma what? 725. Is it 45? 50. That's our break-even point. That's where the lines cross each other. The number of hoodies sold to break even is what then? 30. Right? That's the dead break-even point. So, and that's a good point. So, when you get asked this question, so the break-even point, they want the coordinates. When they ask you the number of sweaters sold, you just have to give me a number. E, if all 650 students in school purchase a sweater, how much profit would the student council make? So 5 times 650 minus 600. Sorry, plus 600. It's going to be a big number. 3850. And then 25 times 650, 16,250. So how much money would they make if every student bought one? 12,400. And so Maddie's got a good point. That's a long question. They're gonna be long questions now. Pardon? I did fast.
Oh, is it good? I think.
That's the problem.
Can I go look now?
Any other questions about this? Okay, you got about 10 minutes. See if you can get through a couple questions. Yeah, go to the